I'm working on the tension problem right here. This is how I have it set up yet, but I'm just having difficulty, like, because I don't know what the tension is, I don't know what the acceleration is.
Okay. What's the problem?
Oh, so that's just gravity, right, pulling on that sucker?
Yeah.
Gravity and
It's not
tension.
moving, yeah.
So you have gravity and tension, the two forces acting.
Yeah, and then you have mass there, so it's just
Mm-hmm.
gravity pulling on that mass. Okay. Cool.
Okay, so you have your that.
Yep.
Then what are these angles?
20, well, rope 1 will be 20, rope 2 will be 30 degrees.
Like that.
Uh,
And how much does the thing weigh?
1100 kilograms.
Yeah, 1100
Times what?
kilograms.
Times 9.8.
Because in kilograms is just a mass. We want a force, which is
Yeah.
times gravity.
Okay, so times 9.
Mass times acceleration is the force. We're good. So that's the fully distributed force on both of the ropes together, and then we do some trig to figure out how much is on each. Is that
Yeah,
am I even
trig
following?
by week.
That's correct. That's totally right.
Okay, because I've never seen this before.
So you do your sum of the forces in the x and your
Sorry.
sum of the forces in the y. That means you break everything up into
Into the
x.
components. Anytime you want to work with vectors and forces.
So that equals to 10,780 newtons.
10,780 newtons.
Okay, so that's a total force between the two.
Now
It's
you
too
draw
bad they're
your
not
arrow.
the same.
You draw your arrowheads there, like that.
Yep.
So this is your free body diagram.
Yep.
Our free body diagram is so important because it tells you the direction and the magnitude of the forces. Sometimes we just don't know the magnitudes yet. This is, let's say B and A,
Yes.
or force 1, force 2.
Mm-hmm.
Depends on whatever's listed. It's a variable, you can do whatever you want.
Book then?
Quick, draw. I'm just kidding.
I'm not that mean to people I don't know. Anyway.
Okay. Does it say it's in equilibrium?
It doesn't say
Doesn't
anything. It just says it's supported by 2 ropes. That's about
So
it.
I assume it's just freehanging the.
Oh,
So we assume
if-
equilibrium.
I'm assuming equilibrium because if it's
Doesn't say
not
otherwise.
equilibrium, then it's broken.
Yeah, and it would be moving.
It would be moving, and it's not moving.
Yeah, okay.
So that means that your acceleration is 0.
Mm-hmm.
Acceleration will be 0. Okay. That's
Which
right.
means our
And that means your sum of the forces, they're both equal to 0.
altogether, yeah.
So then we break it up into x and y. Sum of the forces in the x,
That's tension only.
sine of 30 degrees times force of 2 minus sine of 20 degrees times force of 1 is equal to 0. Sum of the forces in the y,
Okay, so
That's
sine of
gravity.
30 degrees.
cosine of 30 times f2 plus cosine of 30 times f1 minus
Gravity.
10780 equals 0.
Okay. So, question: the sine 30 f2 is that the tension basically, but towards the x
Yeah.
axis, and same thing for the cosine.
Mm-hmm.
That's the tension right there.
Exactly. Yeah.
Okay, so
This is broken up into a triangle. This is the x component, sine of 30 times f1, and y component is cosine of 30 times f1. If you take the sum of the squares, so that squared plus that squared and square root it, you get f1.
right, 30 minus f2
Crazy.
minus sine of 20 minus f. Wait, that it is minus f1.
Yeah. This one,
That should be
yeah,
cosine.
minus f1.
Yeah, okay, now we have cosine 30. Is that minus or times?
Cosine 30, this one,
Times f2?
times f2.
Okay, it's times f2. How come right there is times and it's not a minus?
Which one right here?
Yeah. the
All
color.
the F's are joined by multiplication to the sign.
Oh, really?
Mhm.
That looks
Yeah,
like a
the only
minus.
thing that's happened is in the middle on the top, that's a minus in the middle,
Mhm.
and a plus on the bottom, but the angles are all multiplied by the length of the rope, because that's kind of the hypotenuse, you know?
Yeah.
So if you multiply that number by the sine of the cosine, you get one of the, however they call those things,
Minus one.
components,
Yeah.
or something like that.
So we can solve for F2. F2 is equal to sine of 20, F1 over sine of 30.
Right. And then you plug that in for the y.
Plug that into here.
Yep.
Cosine of
Mm.
30 times sine of 20 over sine of 30. That becomes tangent or
Yeah.
cotangent.
Cotangent.
Cotangent. Times 20 times F1. That's that part. Plus cosine of 30 times F1 is equal to 10780.
Wow.
Solve for F1. That will be your answer. You'll get one number from that because there's only numbers in here.
Okay. Well, that was a little longer than I thought.
Or you just plug it in mathematically and it'll just pop it out.
Yeah, I haven't gone that far.
So it's on the X
So I'm gonna plug that in now. Okay, let me see. So it's 10, 7, 81. Wait. It's not 81, it's 80 actually.
I totally did that on purpose. No, I didn't.
How do you write the cotangent on the calculator?
You can just do 1 over tangent.
Okay. 1 divide that by tangent of 30 times sine 20 plus cosine 30. Hmm. 7,391, well 92 if you round it. That's for rope 1.
What is it, 3,700?
No, 7,391.55.
91 newtons.
It says the two significant figures. So 7.4 times 10 to the third.
And that's, yeah, newtons, because we're just talking about force. That's the only,
Let's see if that works.
it's the only unit we care about.
It did not accept.
Can I see your calculator?
Here you go.
Okay, let's see. So,
I have Mathematica on my laptop if you need it.
oh yeah, that would work. Can you bring it up?
Yep.
I already,
Hmm?
already have Mathematica up.
What?
Mathematica.
I haven't learned how to use it yet, but
If you pick cosine of 20,
oh,
That makes more sense for me, likely. Okay.
if you ever come into a problem, go back to your free body diagram. It will be in there.
Hmm.
It's like almost always in there. We assume it's down here, that we did something wrong with our math. But it's normally always back there in our setup. So remember that when you're doing your problems,
yes.
and you will do good.
I got a new document. So the answer will
F1
now
is
be-
X, F2 is Y.
Okay, X and F2 is Y. Wow, that's really nice. So it's 7.0.
So we were really close.
We
We're off by
were-
like 300.
Yeah. 7.0.
See if it'll take this time.
It took
There
it.
we go.
And
What was it, 7.1?
it was 7.0. And then 4.8. 4.8.
F2 is equal to 4.8 times 10, 3 newtons. Cool. And so to find that, once you find this one,
Yeah.
you just plug it back into here
Mm-hmm.
to find F2.
True. Okay. Thanks.
Legit, you guys, legit. So that calculator does a lot of work, by the way. It's very powerful.
Yeah, thanks for that.
So we didn't, let's see, the Y was what we care about?
Yeah, like we could have solved for F1 up here,
Uh-huh.
saying F1 is equal to sine of 30 times F2 all over sine of 20. See how that's sine of 20, that's sine of 30, sine of 30, sine of 20.
Okay.
We could have solved that and put that into here instead, and just solve for F1 or F2 at the beginning, then yeah. There we could have just solved for F2.